Okay, let's continue working with our ENCOR lab, with our infrastructure lab. And now we're going to talk about the next topic in the ENCOR list. We're going to see troubleshoot static and dynamic ether channels. We are going to talk briefly, as brief as I can, about the theory, and then we are going to go to the lab. The theory part is quite large as any ENCOR topic, but I'm going to try to be as brief as possible. So let's go into it. Ether channels. An ether channel is a logical link made of individual physical links. It provides individual link faults, tolerance, and more bandwidth. So if you basically have two devices and you have more than one link between these two devices, if you configure an ether channel, you can have more bandwidth. For instance, if this was a 1 gigabit per second interface and this was a 1 gigabit per second interface, you will end up with a virtual link of a total of 2 gigabit per second bandwidth. And the Ether channel provides a certain level of resiliency, because if one interface goes down, you will still be still have communication with between these two devices almost seamlessly. That is the other great advantage of Ether channels. Now, Cisco uses this term Ether channel as the product name, but other vendors have other names for the same feature. Other vendors calls these lags, and for instance, Huawei named this feature trunk. So we're going to focus on how Cisco calls this. It is an Ether channel. And first of all, let's talk about what are the rules for individual interfaces that have to comply in order to become part of one Ether channel. They basically must match in their configuration. So if all your interfaces are layer 3 interfaces or routed ports, you can create a layer 3 Ether channel. Now, if your interfaces are layer 2, they must be all either via access or all either via trunk. You cannot combine some interfaces that are operating in trunk mode with some other interfaces that are operating in access mode to create one Ether channel. They all must be operating in the same mode, and if they are operating in access mode, they must have the same VLAN, and if they are operating in trunk mode, they should have the same allowed VLAN list and the same native VLAN. Now, regardless of any mode, they must match in the speed, MTU, and duplex settings. So make sure that your interfaces have a matching configuration, otherwise they will not become part of an Ether channel. Now, how can we classify Ether channels? We can have layer 2 Ether channels that can be operating in access mode, or we can have layer 2 Ether channels that are operating in trunk mode, and we can have layer 3 Ether channels that operate like a routed port in layer 3 switch, where we can apply an IP address. We can have static Ether channels that are configured in such a way that the Ether channel wants to become up instantly. Or we can use a dynamic way to configure Ether channels, where the Ether channel will negotiate whether to become up or down depending on the protocol. We can use two protocols here, PAGP or LACP. We're going to talk about these protocols later on. We can also select one of several load balancing methods for the Ether channel. We're going to talk a little bit later about this. And one important thing to bear in mind is that you can build Ether channels between two devices. As long as these two devices are capable of creating Ether channels, you can create an Ether channel. Most of the people think that you can only create Ether channels between network devices, but bear in mind that servers can also be able to create Ether channels with network devices. So you can pretty much create Ether channels between switches and servers. Bear that in mind. Now, in order to create Ether channels, we have these two building blocks: the channel group and the port channel. The channel group is the actual command that we issue in order to bind individual physical ports together. And then a port channel is created. The port channel is the logical interface. So these are two parts of the configuration that actually build Ether channels: your channel groups, which is actually a command that goes into your interfaces, and the port channel, that is the virtual interface that is being created for you. Now, an interesting thing here is how many individual interfaces can be part of an Ether channel. Well, the question is 8. That is the usual maximum number of interfaces that you can bind together in order to create an Ether channel. Some protocols will let you configure more than 8, but at a given time, only 8 will operate as participating interfaces. The other will be in hot standby mode, waiting for another interface to fail in order to become part of the Ether channel, but the answer is 8. Now, there is an interesting outcome when we use Ether channels. We can forget about spanning tree protocols, putting individual links into blocking mode with using Ether channel, because remember that, for instance, if you had 2 devices and you had 2 links, spanning tree will kick in and will put one of these links in blocking mode in order to avoid this layer 2 loop. With Ether channels, we create virtual interfaces that act as a single interface. So when a spanning tree kicks in and examines this connection, it only sees one interface here and one interface here. So a spanning tree will not block individual interfaces with Ether channels. That is a good thing. Use Ether channel as much as you can in order to get rid of this bandwidth wasting blocking interfaces. So when we have Ether channels, we need a way to figure out how we are going to use these links that are bundled together in order to send frames. So if one frame enters here and another frame enters this switch, let's say frame 1 and frame 2, through what link I am going to send frame 1 and frame 2. So this is where the load balancing method kicks in. The load balancing method will do some calculation with these frames, with the contents of these frames, and will conclude hopefully that frame 1 will be transmitted over this link and frame 2 will be transmitted over this link in such a way that we achieve theoretical 50% load balancing. That will be what we are aiming to in order to guarantee that we are going to use the full capacity of this Ether channel bandwidth. Now, the load balancing method that we are going to pick depends on the topology, and these load balancing methods take into account these frames: source MAC address, destination MAC address, source IP, destination IP, source port number, UDP or TCP number, destination port number, to calculate whether to place a frame in one link or the other. So we have to carefully choose what is the best load balancing method that corresponds to our network topology. So for instance, let's say that we have a layer 2 connection for this Ether channel. So this Ether channel is operating in trunk mode, and this other EtherChannel is operating in throw mode. So we have several MAC addresses that we know on these interfaces, and several MAC addresses that we know from the other side. And the same happens in this switch. Let's say in switch B, we know a lot of MAC addresses that are on our LAN side, and we know a lot of MAC addresses that come from the EtherChannel. So in order to load balance these links, the traffic across these links, the method that makes sense is using the source MAC address and destination MAC address, because we have a lot of MAC address. We have many on this side, and we have many MAC addresses on the other side. So it makes sense to take into account the source MAC address and destination MAC address in order to calculate how to use these two links in a load balancing, in an equal load balancing way. It makes perfect sense because we will have many on one side and many on the other. It creates a scenario with random numbers will appear on either side. So when you have random numbers in your MAC addresses, load balancing between source and destination MAC addresses makes a lot of sense. But what happens if you are still using a layer 2 scenario when you only have one MAC address here and many MAC addresses here? In this case, if we choose, for instance, at switch A to load balance based on destination MAC, given we only have one destination MAC on the other side, the load balancing algorithm will conclude always to use the same link. These are mathematical algorithms, but if you always feed the same number to your mathematical algorithm, the outcome will always be the same. So only one link will be used, so we will have a 100 versus 0 load balance. That is not what we want. In this scenario, maybe we could calculate a combination of source and MAC address here at switch A that will yield a better amount of random numbers. So this algorithm can conclude to send some frames sometimes in this link and sometimes in this other link. And for instance, at switch A, we could choose to load balance based on source MAC. That will also work because we have many source MAC to calculate from. So maybe if we use source MAC, we could achieve a 50 by 50% load balancing. And at switch B, maybe calculating by destination MAC will be good because there are many destination MACs on the other side. So be aware of that. But what happens if we have here a layer 3 EtherChannel on this side and a layer 3 EtherChannel on this side? This EtherChannel interface that we know as port channel only has one MAC, and this one has one MAC. So from the point of view of this switch A, it only knows in the ARP table only one MAC address that corresponds to this switch B. So if I chose at switch A to load balance based on MAC addresses, that will not be very good for load balancing because the load balancing algorithm always end up concluding to use one interface because we only have one MAC address. We only have one MAC address on each side because we are using layer 3 interfaces that have an IP address and only one MAC address. So this doesn't make sense. We will end up having 100% versus 0% load balancing. So we don't want that. So a better solution in this case will be load balancing by IP or by layer 4 ports, which is great. The downside of this algorithm is that not all switches support layer 4 load balancing. The same happens in this case if we only have one IP on one side and many IPs on the other side. If at switch A I chose to load balance by destination IP, that will be a big no. Maybe source and IP destination will be somewhat good, not very good, somewhat good. But in this case, load balancing on layer 4 will be the best because we will be using several different UDP and TCP ports on both sides. That will create a reasonable amount of random numbers, so the load balancing algorithm will randomly be choosing sending packets on this link and other packets on this link, achieving 50% load balancing. That is what we need. Now, how do we configure our port channels? If we are going to configure a layer 2 port channel, the best practice is first using the channel group command. And if we're using generating a layer 3 ether channel, the best practice is first configuring the port channel and then creating the channel, configuring the channel group. That is the order. Don't forget to use the no switch port command, because that will place your interfaces in layer 3 mode. Now, let's talk now about static ether channels. This is a way to build ether channels. When you create an static ether channel, the port channel tries to go into up mode always. Regardless of whatever happens in the network, your port channels want to go up. That is how static ether channels work. They don't negotiate anything with the other side. They just want to go up on each side. So static ether channels don't exchange control frames. As long as a member interface is up, the port channel is up. And this way of configuring ether channels has several disadvantages when compared with dynamic ether channel. The way to do so is when you issue the command channel group, make sure to use the mode on. So mode on is static. So these are what the disadvantages of using static ether channels are. Mainly, if you configure an static ether channel in one side and no ether channel in the other side, spanning tree will be aware of that, and it will going to set your interface in error disabled. First disadvantage of using static ether channels. Then with the static ether channels, given we are not exchanging control frames, device A here is unable to tell that this particular link failed at switch B, because no control frames are exchanged. Under some circumstances, for instance, if you are using a carrier in order to connect both sides, this interface will always remain up, as this is the last mile or local loop connection to your carrier. Even though on the other remote side, this interface has a problem. Static ether channels cannot be aware of that. And for instance, we cannot do port pairing with static ether channels. For instance, this interface believes that it is going to get connected to some interface here, but there is nothing here in the other side. However, this interface will be up, and this third interface could, in this switch, could be going to another third device. And switch A will never be aware of that because there are no frames being interchanged between switch V and A. So A can be aware that the remote interface at B is not even connected. So when sending frames from A to B, some frames can be sent over this interface that is going nowhere, and they will be lost. Okay, this is, for instance, an example of configuring a static Ether channel on one side and not configuring anything on the other side. A spanning tree protocol kicks in and puts all your interfaces in error disabled. All the interfaces that belong to the Ether channel are down and error disabled, and your port channel is error disabled as well. Now, the best practice when it comes to Ether channels is use dynamic Ether channels rather than static ones. Now, let's talk about the first dynamic Ether channel protocol. This is Port Aggregation Protocol, or PAGP, which is a Cisco proprietary dynamic Ether channel protocol. So in order to use this, you will need only Cisco devices for your Ether channel. If you wanted to use PAGP to connect a Cisco device to a Huawei device, that will not work. Now, PAGP uses two modes in order to negotiate whether a port channel will come up, auto and desirable. Desirable always sends PAGP frames. On auto, waits for a frames to arrive before sending PAGP frames. So another channel will never come up if both sides are auto. So if you have auto and auto on both sides, the port channel will be down on both sides. So, but if you use auto and desirable, or desirable and desirable, the port channel will come up on both sides. This is the way to configure your channel group, a number, and then a mode. And these modes indicate that you want to use PAGP. There is no command of enable PHP, such as enable PAGP. So your channel group parameters will tell the operating system that you want to use PAGP if you use auto and desirable or desirable. Now you have two ways to exchange hellos. Fast mode that will send a hello every second between devices, each second, or a slow mode that will send hellos every 30 seconds. And the dead timer, or the way to detect that a device is gone or an interface is gone, is that if you stop receiving hellos from the other side. So if you use slow hellos, it will take longer for a switch to figure out a remote interface on the other side is down or is having problems. So the recommended way is to use fast mode. However, slow mode is the default. In order to use either mode, you go to the interface and configure your rate. PAGP rate, fast or slow. Slow is the default. Now, some miscellaneous PAGP facts. Each PAGP switch is identified by something that is known as the device ID. The device ID corresponds to the device's MAC address. The PAGP frames are sent to this destination address. For PAGP, if you create your port channel as a layer 2 port channel, this port channel MAC address will come from the first member interface MAC address. If you are configuring a layer 3 port channel, the MAC address that is chosen for this virtual interface is assigned when creating the port channel. Now, there are several PAGP features. Probably the most important are the learn method and the port priority. There are two ways to learn MAC addresses in PAGP. Physical, That means that PHP will PHP EtherChannels will learn MAC address per every single interfaces or aggregate. That means that it will only learn MAC addresses per port channel. So if you're using physical, you must use physical on both sides. If you choose to use aggregate, you should use aggregate on both sides. Physical is usually the default mode or method. In order to change your method, use PHP learn method aggregation port or physical port. Now you can select one particular port in your Ether channel for transmission. In order to do so, you can change the port priority with this command. By default, port priority for PHP is 128. It can go from 0 to 255. Higher is preferred. There is another feature that is known as silent mode. This is used if you are connected, for instance, your switch to a server that is only receiving information. So you will be only sending frames to your server, and your server is not actually sending anything back to the switch. That is considered to be a silent device. So it is an obscure feature. Almost nobody uses it. Also, the timeout for informational frames is an obscure feature. Now, what are the troubleshooting commands for PHP? You can use show EtherChannel summary for iOS or iOS XE, or show port channel summary for Nexus. So with show EtherChannel summary, you will be given the status of your port channel. Your port channel status. Remember that your port channel is the logical interface that corresponds to your Ether channel. And this command will give you also the status of every single individual interface that belongs to your Ether channel. So you will have a status for your virtual interface port channel and a status for your individual interfaces. Such status such as it is whether up or down, or whether your individual interfaces are suspended or working as individual, or are administrative down, or are participating. So there are many statuses out there. You can use show PAGP internal to know how your switch where you are working is behaving, under what parameters it is operating, what is the learning method that it is using, whether it is configured or actually sending slow mode hellos or fast hellos, what are the port priorities, and so on. And you can use show PHP neighbor to know how the remote site is behaving, how it is being operating, what is the remote device ID, what is the remote learning method, whether it is sending fast or slow hellos, and so on. So let's see, for instance, an example of show EtherChannel summary. You can see your port channel status and your individual port status. Notice that here it is telling you that you are using PHP for this EtherChannel. Now, when it comes to the port channel status, we are going to use these codes, DRUMSI or DRUMSI. You want to see the capital letter U because it will tell you that this particular port channel is up. You want to see this code. And you will see the code S, capital S, if your Ether channel is a layer 2 Ether channel, or the letter R if your Ether channel is operating in layer 3. So you want to see RU or SU. You don't want to see D in your PHP channel. This M relates to LACP. We are not going to talk about this here now, but we are going to talk about that later. And when it comes to individual interfaces, you want to see this letter. You want to see uppercase P, because that means that the interface is participating in the Ether channel. If this interface is, for instance, in administrative down mode, it will show as D. If the other side is not sending frames, it will be S. It is negotiating, or this is waiting for the negotiation to conclude. You will see a W, and sometimes S or I can happen depending on the device. Usually, PHP sets interfaces that are not receiving frames from the other side as suspended, and LACP usually define them as individual. So this is the other command, show PHP internal. Remember that show PHP internal tells you how your local switch where you're working with now is behaving. We have here an example of how it shows up if your Ether channel is up, and how it shows if your Ether channel is down. So notice, for instance, if it is down, the state or the flags for your interfaces is down. If it is up, it tells you that it is consistent, and for instance, S tells you that it is sending slow hellos. In this case, this hello interval is negotiated. If one side is sending a slow and the other side is sending a slow hellos, the negotiation time is 30 seconds. In any other combination, we will have 1 second. So, for instance, if one side is sending slow hellos and the other side is sending fast hellos, or 2 fast hellos, the negotiated time will be 1 second. You can see the port priority. Remember that PHP uses port priority. That's it. Let's see, for instance, the other command, which is show PHP neighbor. This tells you how the other side is behaving, how it is operating. In this case, the remote switch has this device ID. Remember that every device in PHP has a device ID, which is a MAC address, and it will tell you whether it's sending slow hellos or fast hellos, depending on whether the S, capital S letter shows up here or not. And the remote device is configured to use physical port learning. Remember that there are two learning methods, and remember that this H time is negotiated. Now this is the summary for this particular protocol. PHP uses a device ID, which is a MAC address. It uses 2 modes. Remember that auto and auto mode will make the port channels on both ends to go down. Use auto and desirable, or desirable and desirable. Silent versus not silent. Use silent mode if you're connecting or your switch, for instance, to a server that is not going to send you frames at all. It is going to receive frames from you. You have slow or fast mode hellos that are 1 second versus 30 seconds in that order. You have 2 learning methods per physical and aggregate. We have another obscure feature that is known as reception timer, and we remember that we have port priority can go from 0 to 255, defaults to 128. It will select one interface to send traffic out of the switch, one specific port from all your ports. Okay, let's see the next protocol. This is the other dynamic protocol for EtherChannels, which is LACP. It is a dynamic EtherChannel protocol. It is a standard defined in AO2.3AD. We have 2 ways to configure LACP. We have 2 modes, active and passive. In passive mode, a switch or device will not send LACP frames until receiving 1 frame. In active mode, a device will always send LACP frames in such a way that if you configure one device as passive and the other as passive, the port channel at both sides will be down. So you should use passive and active or active and active, so your port channel comes up. In order to configure LACP, use channel group, the number, and then the mode. Active or passive will indicate LACP. Remember, you do not choose LACP with a command like enable LACP or something like that. When you use channel group with this parameters, you will be choosing to use LACP. We also have slow mode timers and fast mode timers, which are 30 seconds and 1 second. You can, this is the default, the slow mode, and you can configure LACP rate fast in order to use fast mode timers. So this is the dead time. So a neighbor is considered to be dead if you don't receive a hello in 90 seconds for slow mode timers or 3 seconds for fast mode timers. This happens per interface. With LACP, we have something that is known as the system ID. The system ID is made of system priority and MAC address. By default, this is the system priority. You can change it. And you can also change your MAC address with a particular command. This is the way to change your system priority or your system MAC. The system ID is using to define which one of two devices becomes the master switch. The master switch is used to select which interface becomes hot standby when using max bundle. So as a summary, the master switch takes some decisions about some LACP features. The lower system ID is preferred. Now we also have port IDs, which is port priority plus the port number. By default, this is the half of this, like 32,000 and something. This is the default, and we can use this port ID to influence, for instance, when a port will become a hot standby mode when using max bundle. So you can influence your port priority with this LAC port priority at interface mode. And let's talk about these particular LACP features. PAGP doesn't have this. LACP min links will define the minimum amount of participating uplinks to form an Ether channel. This feature works if configured in at least one switch, but it is recommended to configure this at both switches. This is the command. And for instance, if you have switch A here and switch B here, and you had 3 links, and you set min links equals to 2, you will need at least 2 links to be in up state in order for the port channel to remain up. So for instance, if this link goes down and this other link goes down, you only have 1 link up. If your main links are set to 2, this 1 link up does not comply, and then your port channel here goes down and your port channel here goes down. Now the LACP max bundle defines the maximum amount of participating links to form an Ether channel. This feature works if configured in one switch, but it is recommended to be configured on both switches. Use LACP max bundle. So for instance, if you had 2 switches with 3 interfaces and you set up max bundle to 2, then these 2 first interfaces will become in participating mode, so they will become part of the Ether channel, and the third one will remain in hot standby mode. So only two interfaces will be receiving and transmitting traffic, whereas the other is in hot standby mode because you set your max bundle to 2, and in this case you have 3 interfaces. So you have one interface too many. So there are other LACP interfaces that I'm not talking about here, like graceful convergence, delayed LACP, and suspend individual. What happens if you configure, you have this connectivity here between two devices, and you configure LACP on only one side? And when you configure that, your individual interfaces will become in suspended state, because there are no frames coming from the other side, because the other side is not configured yet. Then you will be having a port channel in down state and your individual interfaces in suspended state. So when you have LACP only on one side and you issue show LACP internal, you will see, for instance, that the state is suspended. For some time you might not see anything, but if you wait long enough, you will see that your interfaces are suspended. You will still be seeing how your local device is behaving. For instance, in this example, it is sending a slow LACP frames. It is configured as active. If you configure the command channel group whatever mode active, you will see an A here. If you configure channel group whatever mode passive, you will see a P here. You can see your port priorities, and if you are using enable LACP on one side only and you issue show LACP enabled, you will not see anything, because no neighbors are being seen yet. Now show EtherChannel summary will show, for instance, this port channel is a layer 2 port channel, and it is in down state because only one side has been configured, and your individual interfaces are in suspended mode. Now what happens when you configure the other side? In this case, we have 2 switches with only 3 links connected, and the 4th link has a malfunction. It is not is having a problem. In this case, we can see that my port channel comes up because now I have configured both sides, and 3 of my interfaces are participating. So far so good. We want to see capital P, and one is suspended because there is something on the other side. We are not receiving frames on this particular interface. Now remember that show EtherChannel summary will give you the state of your port channel and your individual interfaces. The codes for the port channel, your logical interface, are these: DRUMSA, drums A. You want to see the letter U in uppercase, because that will indicate that port channel is up. If you see that code, if your EtherChannel is operating in layer 2 mode, you will see SU, and if your EtherChannel is operating in layer 3 mode, you will see RU. On the other side, if something went wrong and your port channel is in down state, you will see RD or SD. So this means that your port channel is down, and this means that your EtherChannel is up. For LACP, you could see the letter M. If you configured min links and you don't have enough links up in order to comply or abide by your min links configuration, you will see that your port channel will operate in M mode. So this happens, for instance, if you had let's say 3 links and you configured min links to 2, and you have 2 links down, you only have 1 link up. That 1 link up is less than 2, so in that case your port channel will show as SM or RM. Remember that show EtherChannel also provides you with the individual states. These are the individual states: I, P, U, S, H, F, R, W, D, and capital D. So for instance, if your interface is in administrative down mode, you will see this. If your interface is still waiting for frames from the other side, it is still negotiating the Ether channel, you will see W. If after some times an interface didn't receive any frame at all from the other side, it can show as S or as an I, depending how you configure your Ether channel. But if a frame is actually participating in an Ether channel that is in up mode, you will see P, capital P. We want this. So show LACP counters will give you a hint of whether an interface is receiving frames or not from the other side. You can use show LACP sysid to see your priority and your MAC address. You can see your local information with show LACP internal. In this case, your interfaces are bundled. Your interfaces for priority are these. And you can see that this device is sending slow hellos and was configured as active. If you had configured this device as passive, you will see a capital P here. You can also use show LACP enable to see how the other side is operating. In this case, the other side is sending slow hellos. It was configured in active mode. The port in the other side has this priority. The other side has this MAC address. And this is the age. For instance, if slow hellos are being sent, you will be seeing that this number goes from 0 to 29 most of the time. So this is the summary for LACP. Remember that we have active mode and passive mode. If you configure both sides as passive, your link will not come up. You have a slow mode and fast mode that will give you 1 second hellos or 30, a slow mode will give you 30 seconds hellos and fast mode will give you 1 second hellos. You can configure a system ID and system priority in order to elect the master switch. Ports have a port priority, and LACP will give you these features: min, link, and max bundle. Now, let's jump into the lab. Okay, in this lab we have access A that will create 2 PAGP Ether channels, 1 Ether channel to switch 3, which is one of my distribution switch, and another Ether channel to switch 4, that is another of my distribution switches. I'm going to create also another channel between switch 3 and switch 4, so I will have my layer through triangle here, and then I'm going to create Ether channels between switch 3 and the DHCP server, and Ether channels between the switch 4 and the DHCP server. I'm going to also use these links between Nexus 3 and Nexus 4 to create 1 Ether channel. So let's do that. Let's go to access A and create the Ether channel. So if I issue show Ether channel summary, I don't have anything. So let's go to interface range, gigabit. In this case, given I am creating a layer 2 Ether channel, I am going to create the channel group first and lay the operating system to create the port channel. So I'm going to use these 2 interfaces, gigabit 00 and gigabit 01. I am just following the diagram, and then channel group, I'm going to call it channel group group that goes from switch 3 to my access 5, so it is 35, and mode desirable, and then if I issue show EtherChannel summary, I will see that I have a port channel 35 created automatically. It is layer 2 EtherChannel because it has a capital S. It is in down mode because the other end is not configured yet. It is using PAGP as the protocol, and these are my individual interfaces. They are in W because they are still negotiating. This W is a temporary state. They end up being a standalone because no EtherChannel was negotiated. So let's configure the other EtherChannel for gigabit 0, 2 to 3. How do I know these are the interfaces? I am looking at my diagram here. Gigabit 0, 2 and 0, 3 goes to switch 4. Then I'm going to create the channel group. Remember that for layer 2 EtherChannels, I will create first the channel group, and the operating system will create the port channel for me. So channel group, let's call it 45, because it goes from my access switch number 5 to switch 4, and then it's just a convention. Mode desirable, and then if I issue show EtherChannel summary, it should be down and waiting because it is still negotiating, and then it remains down. So I'm going to create at switch 3 my EtherChannels. I'm going to create my PHP EtherChannels, and I'm going to create LACP EtherChannels later on to the DHCP server. Now, given these are layer 2 EtherChannels, I am going to configure first channel group and let the operating system to create the port channel for me. So interface range gigabit 20 to 21. How do I know these are the interfaces? Because I am looking here at the diagram. Channel group 3 to 5, mode desirable, and then interface range. I'm going to create in the EtherChannel that goes from switch 3 to switch 4. So that will be gigabit 1, 0 to 3. How do I know these are the interfaces? Because I am looking at this part of the diagram, and then given this is a layer 2 EtherChannel, I have to configure first the channel group and let the operating system to create the port channel for me. So this goes from 3, 4, mode desirable. So if I issue show EtherChannel summary, this goes for switch 4, and this goes for the access switch. As you see, the EtherChannel that goes for the access switch is now up because both sides are configured and they are participating. This is what we want in individual links to be capital P, and for the port channel capital U. So let's go to switch 4 to configure my PHP EtherChannels. First, towards the access switch, it will be gigabit 20 to 21. How do I know these are the interfaces? Because I'm looking here at the diagram, and now given this is an layer 2 EtherChannel, I have to configure first the channel group and let the operating system to create the port channel for me. So channel group, let's call it 45, mode desirable. And then I'm going to create the channel group between the port channel between switch 3 and switch 4. That will be interface range gigabit 10 to 13. How do I know that? Because I am looking here at the diagram that these are the interfaces. And then given this is a layer 2 Ether channel, I have to configure the channel group first and let the operating system to create the port channel for me. From 3 to 4, mode decidable. So all the Ether channels are created to create this layer 2 triangle. So layer 2 up, participating, layer 2 up, participating, layer 2 up, participating, layer 2 up, participating. Layer 2 participating. Now I'm going to create layer 3 Ether channels from switch 3 to the DHCP server. So let's create them. In this case, given I am going to create a layer 3 Ether channel, I have to create first the port channel. So let's create the port channel. Let's call it from switch 3 to device 6. And I have to issue the command no switch port to turn this port channel into layer 3 mode. Then this will be my port channel for my users VRF. And then I have to assign an IP address 10.1 from switch 3 to device 6. And then I am going to execute my channel group 30 to 31. How do I know these are the interfaces? Because I can see these 30 and 31 in this diagram. Range and then channel group. Notice that given this was a channel, a layer 3 Ether channel, first I create the port channel and then I execute the channel group. This was the 36 mode, and in this case, given I am going to go for LACP, I have to choose between active and all between passive and active. So let's do that. Active. Oh, I have to turn them into layer 3 with no switch port. I forgot to do that. And that's it. And then I'm going to create the other LACP layer 3 Ether channel. I'm going to call it 37. Sorry. Interface port channel. Remember that I am creating another layer 3 Ether channel. In the case of layer 3 Ether channels, I have to create the port channel first and then the channel group. So let's say 37. No switch port to indicate this is a layer 3 port channel. And then I'm going to bind it to the guest VRF. I am using different VRF for security. All the users that belong to this enterprise will go to the VRF users, and guests will have their particular VRF. So that is why I'm separating the connection to the DHCP server for VRF per VRF for users and for guests. So it will be 10.1 3 to 6 and 3 and shoot. and then I'm going to execute the channel group range gigabit 32 to 33. How do I know these are the interfaces? Because I am looking here at the diagram. Now switch port to turn them into layer 3 ports, and then channel group 37 mode active. So if I issue show EtherChannel summary, I have two PHP EtherChannels and two LACP EtherChannels. Notice that when an interface in LACP does not negotiate an EtherChannel, it becomes in suspended mode, whereas PHP goes into individual mode. Now let's go to switchboard and do the same. I am going to set up this as a layer 3 EtherChannel that belongs to the BRF users. After setting up the port channel, I have to execute the channel group command. 30 to 31. How do I know that these are the correct interfaces? Because I am looking at this diagram, 30 and 31. No switch port to turn them into layer 3, and then channel group 46 mode. Remember that active for LACP. I could use passive for as well, and no shoot. I'm going to create. Go ahead and create the other EtherChannel, the final EtherChannel interface port channel. In this case, 47. No switch port to indicate it is a layer 3 port channel, and then I'm going to bind it to the guest BRF, then an IP address 10.1.146.4.55.0, no shutdown. And remember that for layer 3 EtherChannels, I first define the port channel and then the channel group. So let's do the channel group. Gigabit 32 to 3. How do I know these are the interfaces? Because I am looking here at the diagram. No switch port to turn them into layer 3 interfaces, and then channel group 47 mode active. So this will be my EtherChannels. These show up as D. That means that these interfaces are in administrative down, so I'm going to issue should not shut down. Okay, now they are W. Remember that W is a temporal state where the interface is negotiating with the other side. They are both down. R because they are layer 3 EtherChannels, but they are down because I have not configured the other side, which is the DHCP server. Let's go and do that here. Interface port channel. Uh, 36 BRF forwarding users. IP address 10.1.36 AM6. shoot. I am going to create the port channels first. Okay, I have created the port channels, but they don't have any member interfaces, so I'm going to do that. Interface range gigabit 1 and gigabit 2, and channel group 36, mode active. And then gigabit 3 and 4 will be channel group number 37, mode active. I'm going to disable the warnings. How do I know what interfaces belong to each Ether channel? Because I'm taking a look at these interfaces here in the diagram. So interface range gigabit 5 and gigabit 6, channel group 46, mode active, no shoot. And then interface range gigabit 7 and gigabit 8, so in this router I have seen this came up, this came up. I have this in down because these interfaces are not up. Gigabit 3 and 4 are not working for some reason. Oh, okay. Oh, suspended. Ah, there it is. It is working now. So all my Ether channels are up and participating. Layer 2 up, layer 2 up, layer 3 up, layer 3 up, participating. Layer 2 up, participating. So let's do LACP on these Nexus switches. I am using Nexus because the LACP implementation in Nexus is more complete than the LACP implementation here in this. For instance, in this switch, if I go to gigabit 2.0, for instance, and I wanted to enable LACP rate, I don't have LACP rate. I don't have LACP rate. And or for instance, if I wanted to enable for instance, max bundle or min links, min links, I don't have min links here. So this implementation of LACP in these switches lacks min min links and fast rate. So I'm going to do that here in this Nexus. First of all, we have to enable LACP. Remember that in Nexus we have to enable feature by feature. So let's enable feature LACP. Otherwise, the commands for LACP will not be available. So first we enable LACP, then let's configure my interfaces. This will be only a layer 2 Ether channel, so I'm going to go for the channel group configuration first, and I will let the operating system to create the port channel for me. So from 1.5 to 9. How do I know these are the interfaces? Because I am looking at these interfaces here in the diagram. And then channel group 3 to 4 mode active. But I am going to set up LACP rate. Notice I have this option here, LACP rate fast. And then I'm going to create the channel group. And then I'm going to do the same here. Interface from Ethernet 1.5 to 9. How do I know these are the interfaces? Because these are listed here in the diagram. And then channel group 34 mode active. Then I'm going to configure min links and max bundle. So let's go to the port channel, interface port channel 34, and let's do LACP min links to 2. So I need at least 2 interfaces to be up, so the port channel remains up, and then max bundle to 4. So even if I have more than 4 connections between these two switches, only up to 4 interfaces will be participating in the port channel. I'm going to leave it at that. So let's issue show port channel. In this case, it's show port channel for Nexus. It is layer 2 and down. Something is going on. Port channel summary. These interfaces are administrative down. That is why it is not coming up. So capital D means the interface is, for instance, in administrative down state, so no shutdown. Okay, now we have participating interface. And one in D mode. I don't know what is in D mode. Okay, this is in hot standby mode because we configured max bundle, so only 4 interfaces can be participating, and the 5th will become hot standby, waiting for any of these interfaces to fail in order to participate into the Ether channel. Now, in this case, given I didn't configure the same, the configuration is not the same in both switches. For instance, I have here the min links and max bundle. When I have here max bundle, this command output gives me enough information to know this is in hot standby mode. Whereas on the other side, I don't have configured the max bundle command, so the only information that I get is that it is in a suspended mode. I don't have enough information to know that this is in suspended mode because the other side is in hot standby mode. So the best practice is configuring the same on both sides. So I'm going to configure both switches the same with the same commands. So now that the configuration is consistent, now I know that this is not participating because it is in hot standby mode. Now, what if I wanted interface 9 to be part of the bundle and leave other interface in hot standby mode? So I can configure the LACP port priority and set it to a lower value so the interface 9 wins over other interfaces. So let's do it on both sides. And then after doing that, now interface 9 is participating and 8 lost the priority battle and it is now 8 in hot standby mode. Now let's test the main link configuration. Let's shoot down 4 interfaces, so only one interface remains down. 1, 5, 2, 8, and I'm going to shoot them down, so only one link will remain up. Now, given only one link remain up, this is not complying with the min links configuration of 2, so now the status is M, capital M. Remember, capital M means not in use due that min links not met. So we don't see a capital D here as down, but we see a capital M because not in use due to min links not met. Okay, just to finalize, let's show all the other troubleshooting commands. Show PHP counters, show PHP internal, show PHP neighbors, show PHP counters, show PHP internal, show PHP neighbor, show LACP counters, show LACP internal, show LACP neighbors. Okay, that's it.